Hey folks, I'm taking a look at one more trigonometric integral. This one is tangent cubed 4x dx. So this is involving tangent. So again, let me come over here and write down off to the right things that pop into my head when I see tangent. When I see tangent, one of the first things I write down is the trigonometric identity of 1 plus a tangent squared is equal to secant squared. And let's see some other things. Well, we know the derivative of tangent. Let's see, derivative of tangent, you should know that, is secant squared. And, oh, just for completeness sake, it's always good review. Let's go ahead and write down what the derivative of secant is. Derivative of secant is secant tangent. And again, these are going to be my weapons that I'm looking at when I'm attacking this problem. So now I come back and I see this tangent cubed 4x. So the first thing that pops into my head is let's go ahead and let's rewrite this beastie as just a tangent 4x times a tangent squared 4x. And sure enough, I see that tangent squared. I have a Pythagorean identity that's going to tell me how to rewrite that tangent squared. I'm going to rewrite it as a secant squared minus 1. So let me go ahead and rewrite this integral as a tangent 4x times secant squared 4x minus 1. And let me go ahead and distribute that tangent 4x. And let's look at what that gives me. That gives me the antiderivative of tangent 4x secant squared 4x minus the tangent 4x dx. All right, so believe it or not, well, let me go ahead and just split this into two separate integrals. And when I split it into two separate integrals, I'm going to say that I think the second integral, I'm going to say I think that's a pretty easy one. Now, I'm saying I think that's a pretty easy one because, in Calc 1, when we first learned U substitution, we ended up coming up with a formula for the antiderivative of tangent x. You remember in Calc 1, you ended up rewriting the tangent x as sine x over cosine x. You let u equal cosine, and you were able to come up with a formula. Well, that formula you came up with is that the antiderivative of tangent is negative natural log absolute value cosine x plus c. Some people also say, well, you could take that negative sign, that negative 1, and you could put it up in the exponent position, and that would give you another formula for tangent, the antiderivative of tangent, being the natural log absolute value of secant x plus c. Now, I think the only people that do that are the people that have a lot of free time on their hands. I would like you, I fully expect you to know that the antiderivative of tangent x is the opposite natural log absolute value, cosine x. All right. That makes the second integral here a pretty easy integral to do because look, we're going to be able to knock that out in one step. It's going to be negative 1/4 natural log absolute value cosine 4x. All thanks to just knowing the antiderivative of tangent x. The first integral here shouldn't be too much problem either. If we just kind of look at it as being a basic u sub. U is tangent 4x. And then du, well, you should have du to be a 4 secant squared 4x. U goes in for the tangent 4x. Your secant squared 4x dx, well, that's taken care of by 1/4 du. And yeah, we'll put the 1/4 out front. And then we've already talked about how this last integral is going to be a piece of cake. Finishing it off, antiderivative of u is 1/2 u squared. So that gives us a 1/8 u squared. The antiderivative of tangent 4x is negative 1/4 natural log absolute value cosine 4x. So minus a negative gives us a plus 1/4 natural log absolute value cosine 4x plus c. And then resubstituting in, we finally get the antiderivative of 1/8 tangent squared 4x plus a 1/4 natural log absolute value cosine 4x plus c. And that's all there was to that one. So I hope you found that to be a pretty friendly integral, trigonometric integral to do. And that's it. Thanks for watching.